All right, everyone, let's take a look at these two tables here, and let's try to write the appropriate functions which each table represents, okay? So let's take a look at the table to the left. Okay, so we remember we have the x values in one column and the corresponding f of x values in the other column, right? So let's look at the table to the left. That's this orange one right here, right? So when x equals 0, f of x equals 40. When x equals 1, f of x equals 60. X equals 2, f of x equals 80. X equals 3, f of x equals 100, right? Okay, so is this a linear function or is this an exponential function? Well, we have to look at by how much the output changes each time, right? Okay, so we go from 40 to 60, from 60 to 80, from 80 to 100, right? Is that changing by the same amount each time? It is, right? It's changing by positive 20 each time, right? Changing by positive 20 each time, right? So f of x, writing in orange here, f of x is linear, right? Is linear. We still have to keep our linear functions in mind. We need to be able to know when a function is linear and when it is exponential, right? So let's remember how to write a linear function. That's going to be f of x equals mx plus b, right? Where m is the slope of the line or the rate of change, and b is the y-intercept or the initial value, right? Okay, well, what is m? What's the rate of change here? Well, the rate of change is by how much the output is increasing each time, right? And we're increasing by 20 each time. So the rate of change or slope of the line is positive 20, right? And b is what? B is what? Well, B is the y-intercept, right? That's the value when x equals 0. And what's the value when x equals 0? It's positive 40, right? Positive 40. So we can say that f of x is equal to 20x plus 40, right? And that wasn't so bad. We had a lot of practice with that in the last topic we spent time on, right? Okay, so let's switch over to green and let's look at our green function, right? That's g of x. Is g of x linear? Let's find out. Well, we go from 1 to 7. That's a change of plus 6, right? We go from 7 to 49. That's a change of what? That's a change of like 42, isn't it? So already we know g of x is not a linear function. So it's most likely an exponential function, right? In this case, it is an exponential function, right? So what's the common ratio in this case? We could just look at it and you might be able to tell just from looking that the common ratio is positive 7. But if we didn't know that, we can always find the common ratio, right? We could take one output and divide it by the previous output. We could do 7 divided by 1, which is 7. We could do 49 divided by 7, which is 7, right? We could do 343 divided by 7. In any case, they're all equal to 7, right? Remember how to find the ratio of a geometric sequence or an exponential function. You always take one output and divide it by the immediately previous output, right? And you're going to get, in this case, positive 7. The common ratio is positive 7. So g of x is exponential. G of x is exponential. It equals a times b to the x power, right? Where a is the initial value and b is the common ratio. Okay, so what's a? A is the initial value, or the value when x is equal to 0, which we see is positive 1, right? And what's b? The ratio? The ratio is positive 7, right? So we can write g of x. We can write g of x is equal to 1 times 7 to the x power. Of course, if we're multiplying by 1, right, we often don't explicitly write that, right? So we can just say g is equal to 7 to the x power. Okay, let's look at this. Let's look at just the table of an exponential function, all right? H of x, we're just going to say we already know is exponential. We could have told that by looking at it, right? So h of x is definitely going to be equal to a times b to the x power, right? Okay, so how can we write the equation for h of x then? All right, let's look at our table. When x equals 0, h equals 3. When x equals 1, h equals 2. When x equals 2, h equals 4/3 or 4 over 3. And when x equals 3, h equals 8/9 or 8 over 9. Okay, so we should be able to find a right away, right? We should be able to find a because we know for one that the y-intercept, right? Y-intercept always occurs at the point 0, comma a, right? And we know that a, right? A is the value of the function when x equals 0, or should I say h of 0, right? Always equals a, or g of 0 always equals a, or f of 0 always equals a, right? In any case, if you have an exponential function, your value of the function is always going to be a when x equals 0. And in this case, what is the value of h of x when x equals 0? It is positive 3, right? So we know already that a equals positive 3. So let's update our information. We now know that h of x equals 3 times b to the x power, right? So b is the common ratio. All right, how do we find the common ratio now? Okay, so I want to go through two methods you can use, right? So remember, when evaluating the common ratio of an exponential sequence, right, you can always take one term and divide it by the immediately previous term, right? So how do you sort of represent that idea when dealing with a function? Well, I'll show you. You can always take, in this case, let's say h of x, and you can always divide h of x by h of x minus 1, okay? You can always take the value of the function for any input and divide it by the value of that function for the input minus 1. All right, to make that a little maybe more understandable, here's what I mean. We can take, for example, h of 3 and divide by h of 2, right? We can take, for example, h of 2, right? And divide by h of 1, right? Or we can take, for example, h of 1, right? And divide by h of 0, right? In any case, that's always going to equal your common ratio b. Okay? So in this case, why don't we just take h of 1 divided by h of 0, okay? Why don't we take h of 1 divided by h of 0? H of 1 is going to be 2. H of 0 is going to be 3. So we've got our common ratio already. Already, b we know is equal to 2 over 3. All right, so let me take this. Let me make some room to write that down. Let me make some room to write that down. So we already know that h of x, right? We already know h of x is equal to 3 times 2 over 3 to the x power, right? How else maybe could we have solved this? Let's see. Let me get some room. Let me get some room over here, maybe. Let's get some room right here. And let's go ahead and know that we have h of x, right, is equal to 3 times b to the x power. Well, what we could have done is just picked any value of x and just substituted that value in. Let's look at what I mean by that. Let's say we took h of 1, right? Let's say we took h of 1, and that's equal to what? That's equal to 2, right? H of 1 is equal to 2, right? Okay. Well, we know from our formula, h of 1 is equal to 3 times b to the first power, right? And we know that's equal to 2, okay? And b to the first power, right? Well, that's just b, right? 3 times b equals 2, right? And what can we do? We can divide by 3 on both sides, right? Cancels out there, and we're just going to get b equals 2 divided by 3, or 2 over 3, which we know in fact to be the common ratio.